Welcome you all to our mathematical park. We are excited to take you all on journey where math becomes fun, creative and fun happy mindless. I am Sufyan from 6th grade. I am Ashita from standard 6. In this park, we are eager to show about 2D shapes of rectangle, triangle, square and trapezoid. Rectangle has 4 sides, while the opposite sides are equal.
Next, we are excited to present our model, the smart slide. You may have seen many slides in past, but have you ever thought about the math behind the slide? Each step defines the measurement unit from smallest to large. Set millimeter, the smallest unit of length. It is used to measure medium-sized objects like the thickness of a coin. 10 millimeter equal to 1 centimeter. Next is centimeter. It is bigger than millimeter. It is used to measure medium-sized objects like an eraser, coin, etc. 1 centimeter equal to 10 millimeter. Next is decimeter. It is used to measure medium-sized objects like tablet or a plate. 1 decimeter equal to 10 centimeter. Next is meter, the standard unit of length. It is used to measure a classroom, auditorium, etc. 1 meter equal to 10 decimeter. Next is mechanical. It is the biggest unit of length. It is used to measure large areas like small playgrounds. 1 decameter equal to 10 meters. Next is hectometer. It is used to measure the large places such as a school ground. 1 hectometer equal to 100 meters. Next is kilometer. It is the largest commonly used unit. It is used to measure the length of a road. 1 kilometer equal to 1000 meters. Thank you.
Nalini from standard 6. I am British from standard 6. Next we see about playing numbers. Prime numbers, even number, odd number. Prime numbers stand tall. Even numbers glide in pairs. Odd numbers stay playful. Together they color the sky like kites. Prime numbers are the special heroes of the number world. Each prime stands with only 2 factors, 1 and itself. 2 is only even prime number. All others are odd. Example 2, 3, 5, 7, 9, 11, 13, etc. Even numbers are the compound. They now share things equally. If you try to divide them into 2 equal groups, they never complain. It always works. Even numbers starts with 2, 4, 6, 8, 10 and ends with 0, 2, 4, 6 or 8. Odd numbers are the playful ones. They never be split into 2 equal parts without one extra left behind. Odd numbers start with 1, 3, 5, 7, 9 and ends with 1, 3, 5, 7 or 9. Thank you.
I am Ahmad from 6th. I am JSK from 5th. These are the protractors, stretch colors, copper and rulers. They are collectively called as math geometry tools. It is used to draw and measure shapes and angles. First, protractor. A protractor is like a thumbnail. Next, angle. They construct angles of acute angle measures less than 90 degrees. Right angle measures exactly 90 degrees. Obtuse angle measures more than 90 degrees. Right angle measures 180 degrees. Reflex angle measures more than 180 degrees, less than 360 degrees.
Ruler is used to draw straight lines. Copper is used to draw circles or not. The square is used to draw right angle and other triangles. Thank you.
I'm Sanjay from 6th. String I. Feel the sky. The string is not just fun. It is a travel around the number line. The straight line begins with 0, the long center. Move to the right and the numbers move downward. Plus 1, plus 2, plus 3, etc. They are called as positive integers. With the number now drift to the left and the numbers become smaller. Minus 1, minus 2, minus 3, etc. They are called as negative integers. With the number lines, that's become special. We don't imagine numbers, we watch them travel. That's why the number line is one of the most important tools in mathematics. Thank you.
Hello, I am Kadya from Standard 16. This is seesaw model. This model helps us to compare two numbers greater than, lesser than and equal. 8 greater than 5. This symbol denotes as the greater than symbol. 4 lesser than 7. This symbol denotes as the lesser than symbol. 6 equal to 6. This symbol denotes as the equal to symbol. Thank you. I am Miss One from Standard 16. We introduce our Ferris wheel as the giant magic wheel of mass. Ferris wheel does not spin randomly. Each cabin moves in a fixed rhythm. Maths works the same way. When solving expression, we follow a special order, just like the sequence of cabin on a Ferris wheel. 4 math, P for bracket, O for order, D for division, M for multiplication, A for addition, and S for subtraction.
B for brackets. The cabin on the bottom is inside brackets. S for security. Inside the ticket. O for orders. Squares, roots, powers. These are the Bosco of numbers. Division. The process of splitting something into equal parts. M multiplication. This group travel side by side. A addition. The process of putting things together in total. S subtraction. This constructs the term ending of the calculation pattern. Just like a telescope that in a fixed pattern, maths also follows a fixed order than you.
I am Ajula from Standard 16. Welcome to our mathematical 3D world shape. Jump out of the paper and come alive. Here you will see an amazing models like cube, cuboid, sphere, cone, cylinder and hemisphere. Cube. A cube is a 3D shape with 6 equal square faces, 12 equal edges and 8 equal vertices. Here is the real life example of cube is dice. Cuboid. A cuboid is the box-shaped 3D figure. The length, breadth and height are all different. Mobile phone is the best example for cuboid. Sphere. A sphere is a round 3D object like a ball with no edges or corners. Example, globe. Cone. The cone is a 3D shape with circular base that tapers smoothly to a single pointed tip. Cylinder. A cylinder is a 3D shape with circular faces and one curved surfaces. Example, drums. Hemisphere. A hemisphere is a 3D shape that represents half of a sphere. That is the best example for hemisphere. Thank you.
Thank you for strolling through our mathematical power. Today it shows that maths is not a subject we just thought. It is a playground that creates. Thank you and visit us again.
Do you know that honeybees are the best architect? I will explain you why. Let's see the honeycomb. The hive is not only the bee's nest, the place where bees store their honey. If you see any honeycomb, you could see it is constructed from tightly packed external shape. But why external shape? Why honeybees don't start use any other shape like circle, square, and triangle? If the honeybee started with their random shape, what would be the next cell? It should customize that it should fix with the first cell. Then the third cell will have to be designed. So, fit the first two cell. This method takes more time of constructing the honeycomb, but the bee should work one at a time. To avoid this, the shell should be some shape and size. You can also think about sphere, triangle and square. The honeycomb built with a sphere leaves little gap between them. The scraps needs extra wax to fulfill for patching.
So, honeycomb from a sphere is not a good idea. You can also think about pentagon or octagon, but all the shapes create gap between them. The shape like triangle, square and hexagon does not create gap between them. But among them, hexagon has the smallest total perimeter. The others, it is compact than others.
You must upload bubbles. When you know more than one, you may notice that the first ones are circular.
Excuse me, miss, my coming.
But when there are more bubbles attached, they take a hexagonal shape. The shape happens in a height. The back cells next to each other at first circular, but later due to the use of space, they also take hexagonal shape.
This is the reason why honeybee build their honeycomb in hexagonal shape.
Thank you.
Good morning. I am Matriculation from 17. Today I am going to explain about the Phoenix Fish problem. Phoenix Fish was a Persian town with 2 islands and 7 villages. Phoenix Fish was a city with a river flowing through it, dividing the lands into 4 parts. There were 7 bridges connecting these land areas. The problem is it possible to cross all the 7 bridges, but where you only cross each bridge only once. You can start and finish wherever you like. To solve this problem, a mathematician named Leonard Euler studied this problem in 1736. Instead of using this actual map, he simplified it. Each land area has a point, each bridge has a line. This type is called as a graph.
If the landmass have an even number of bridges or axes, then if you enter one, you could exit from it without the need to go back. Euler discovered an important rule. If you want to cross every bridge exactly once, all points must have an even number of bridges, or only 2 points must have an odd number of bridges. If the landmass have an odd number of bridges or axes, then if you enter one, you could not exit from it. But in Koenig's bridge problem, all 4 land areas must have an odd number of bridges. According to Euler's rule, it is impossible to cross all 7 bridges exactly once. This problem is very important because it led to the development of new field in mathematics called graph theory, which is used in CS, road networks and communication system. Thank you.
Good morning, Madam and sir. I am Himachal of class 7. Have you ever seen a shape that looks like same no matter how much improvement? That kind of shape is a fractal. This is the most famous of the Sierpinski triangle. The Sierpinski triangle is the famous ones discovered by Polish mathematician Wacław Sierpinski in 1915. A fractal is a shape that same pattern again and again in different sizes. This property is called self-similarity. In this triangle, even though keep removing the boundary, the area keep increasing. This shows how simple roots can create infinity and beautiful in mathematics. I teach you to construct a Sierpinski triangle. Start with a large equilateral triangle. Join the middle of the 3 sides. This forms a 4 more larger triangle. Remove the mid-side. Continue forever. We can get a Sierpinski triangle. We can see this in snowflakes, antenna, farm leaves and plants, computer graphics and digital art. It is helps in mathematics because it helps us to understand the comfort of infinity. It helps in modern technology. Sierpinski triangle proves that mathematics is not just about the numbers, it also about the patterns, just like utility. It keeps growing and revealing new patterns. That Sierpinski triangle, why fractal like Sierpinski triangle. That's why fractal like Sierpinski triangle are fascinating and important to study. Thank you.
My name is from class 7. I am Netra from class 3. The Rossi series is a sequence of numbers where each root is sum of 2 before it. 0,
5, 8, 13, 21, etc. This pattern appears surprisingly often in nature, and one of the most beautiful examples is the sunflower. If you look at the sunflower center, you will notice that the tiny florets are arranged in a spiral that radiates outwards. The spiral are not random but follows the Fibonacci series. In most of the sunflower, the number of spirals curving clockwise and the number curving clockwise are consecutively Fibonacci number, such as 34 and 55 or 55 and 84. These arrangements allow the sunflower to pack the maximum number of seeds into the smallest possible space. The introduces the Fibonacci pattern because it is essential, ensure, and each seed receives sunlight and nutrients without wasting space.
A nautilus is a sea animal that lives inside a beautiful spiral shell. When we look at the shell shape, it forms a spiral that grows bigger and bigger. This spiral shape is very similar to a Fibonacci spiral. If we draw squares using Fibonacci numbers as side tens, 1 into 1, 1 into 1, 2 into 2, 3 into 3, 5 into 5, and draw a curve through the corners, we get the spiral. The nautilus is a sea animal that lives inside the beautiful spiral shell. When we look at the shell shape, it forms a spiral that grows bigger and bigger. This spiral shape is very similar to the Fibonacci spiral. If we draw squares using Fibonacci numbers as side ends, 1 into 1, 1 into 1, 2 into 2, 3 into 3, 5 into 5, and draw a curve through the corners, we get the spiral. This spiral looks very similar to the Fibonacci spiral. This number is called the golden ratio, and it appears in art, architecture and nature. And draw a curve through the corners, we get the spiral. This spiral looks very similar to a spiral of the nautilus shell. When we divide the Fibonacci number by the previous number, the answer gets close to 1.618. This number is called the golden ratio, and it appears in art, architecture and nature.
You can see the spiral of the pineapple. It follows the Fibonacci series to absorb the sunlight evenly. Also, the leaves arranged in plants, it's also following the Fibonacci series to get sunlight to all the leaves.
The Fibonacci series teaches that even simple number can create extraordinary patterns, proving that mathematics is truly the language of nature. Thank you.
Good morning. I am Sushma. Good morning. I am Sushma of class 7. I am Sudarshan of 8. Have you ever seen this symbol? It looks like a table. It's a Greek letter pi. The symbol has lots of figures. It stands for number that never ends. It keeps going and going. It is very important in the studies of circle. Pi stands for ratio between circumference and diameter. The diameter is the distance across the circle. The circumference is the distance around the edge of the circle. Pi is the ratio between circumference and the diameter. No matter how big or small the circle is, this ratio is always the same. I will show you how. Measure the circumference. This circumference. Now measure the diameter. Divide the circumference. Divide the circumference with the diameter. This is the remaining part. Now we will measure the other small circle. Measure the diameter. Now measure the circumference. Divide the circumference with the diameter. This is the remaining part. These two remaining parts are always being zero. This blue pi is constant for every value. Engineers use pi to build roads, gears and pipelines. Doctors use pi to scan round objects. Architects use pi designing their domes and arches. Without pi, modern constructions would be impossible. Today, we are learning pi is not just a number, it's a special number that appears in every circle around us. From beans to coins to pizzas, pi helps us to. Pi is the most fascinating number. And even today, mathematicians Computers are still finding more digits. It is a bridge between real world and maths. To recognize its beauty, Pi Day is celebrated on March 14. Thank you.
Good morning everyone. My name is Kumar Prasaviji. Today I am going to show you a mathematical puzzle called a diagram. Diagram is an ancient Chinese puzzle made using geometry pieces called tang. Using these pieces, we can create hundreds of different shapes and more without overlapping. A diagram is more from one square cut out of there are two large triangles, one medium triangle, one square, one parallelogram, two smaller triangles. A diagram is a geometrical puzzle game that used to most vital ability of geometrical figure. Thank you.
for the conceptual learning in the amazing world of maths. Maths is all about numbers, which are the fundamental building blocks of mathematics, essential for counting, measuring, labeling, and performing calculations. I would like to recite a number dice which tells you the importance of numbers in our daily life. Numbers all around, everywhere they are found. Numbers tell how old I am and how many people in my family. When to wake up and when to eat, what size shoes to buy for my feet, how much money something costs, a number to call if my dog is lost. Here comes Dylan to explain the types of numbers and the position of the number in the number line.
The number starts from 1 to infinity are natural numbers. The number starts from 0 to infinity are odd numbers. Integers are the numbers which are both positive and negative numbers. Even numbers are divisible by 2. Other than even numbers are odd numbers. Prime numbers are the numbers which has two fractions. Other than prime numbers are composite numbers. Rational and irrational numbers are root 2, prime and fractional numbers. Number line. An upper line is a representation of numbers in the line. An upper line consists of positive numbers, negative numbers, and zero, which is neither positive or not negative. The numbers are arranged in increasing order horizontally from left to right or vertically from the bottom to top. In real life, we use these number lines to add, subtract and multiply. The thermometer we use to find our body temperature is a number line. The distance between two places is also a number line. The distance we reach is denoted in positive sign. The distance we have to reach is denoted in negative sign. An aeroplane flying at the height of 2000 meters above the sea level is positive, whereas the depth of submarine or fish under the sea is denoted in negative sign. Thus, we use number line in everyday life. Thank you.
For calculations, we need factors and multiples of numbers. But what are they? Hansuja is here to explain the factors and multiples.
I am going to explain about multiples and factors. Multiples of a number are many, whereas the factors of a number is limited. We can say the number of leaves in a tree as multiples, whereas the number of flowers are examples of factors. Now I am going to tell you about LCM and LCM, least common multiple. The smallest number that is multiple of all given numbers. Example 3, 6, 9. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27. The multiples of 6 are 6, 12, 18, 27. The multiples of 9 are 9, 18, 27. Yet we see 3 pigs in 18, so LCM is 18. HCF, the highest common factor, the biggest number that divides into all given numbers without leaving the reminders. Example 3, 6, 9. The factors of 3 are 1, 3. The factors of 6 are 1, 2, 3, 6. The factors of 9 are 1, 3, 9. Hence we see 3 ways in 3, so HCF is 3. Uses of LCM and HCF in our daily life. Let us consider two buses arriving at the intervals of 15 and 20 minutes. We can find the next arrival of both the buses together by finding the LCM of 15 and 20. LCM of 15 and 20 is 60. So both buses arrive together after 60 minutes. Example of HCF. Distributing 15 apples and 40 bananas equally among orphans. In this case, we must find the HCF of 15 and 40 is
8 bananas each. Thank you. These numbers got their names. Kavita will explain about it and she will also tell us the types of angles.
I'm going to explain the hidden truth behind numbers. Can you tell me how numbers got their name? Well, I'll explain you. There is only one angle formed in number 1. Hence, it is named as 1. There are 2 angles formed in number 2. Hence, it is named as 2. Similarly, 3 angles in 3, 4 angles in 4, 5 angles in 5, 6 angles in 6, 7 angles in 7, 8 angles in 8, 9 angles in 9, and at last there are no angles formed in number 0. Hence it is named as 0. Now I tell you the types of angle. Acute angle. Acute angle. An angle whose measure is less than 90 degrees is called an acute angle. Right angle. An angle whose measure is equal to 90 degrees is called right angle. Obtuse angle. An angle whose measure is greater than 90 degrees is called an obtuse angle. Straight angle. An angle whose measure is equal to 180 degrees is called an straight angle. Thank you.
Numbers can be squared to increase in value and the increased value can also be decreased by finding its square. Here comes Ilakya to explain us how this square grows in size.
Square root square. A square root square of square of geometry. See how they obtain the number like root 2 plus root 4. It starts with an isosceles right triangle. Take 1 and 1. Hypotenuse root 2 and continues by using the next triangle, creating an exponent spiral where hypotenuse measures root n. It provides a beautiful geometry way to see how the irrational number like root 2, root 3 grows. It starts with an isosceles triangle, also called Pythagorean spiral or Pythagorean snake. The real life example of square root spiral is a lighthouse. If we see the lighthouse from the bird view, it completely looks like a square root spiral. Thank you.
Here is a short test for you to match the algebraic identities. Now Kavita will tell you what to do.
These are some of the algebraic identities you have to match the question with the correct answer. A square minus B square is equal to A plus 3 A minus B.
Now we are going to enter into the world of shapes. Now Saranya will tell you about the polygons.
A polygon is a closed shape formed by 3 or more sides. If all sides are equal in a polygon, it is called as regular polygon. A polygon with the 3 sides is called a triangle. 4 sides are square, rhombus, parallelogram, trapezium, quadrilateral, triangle, rectangle. 5 sides shape is a pentagon, 6 sides shape is a hexagon, 7 sides shape is a octagon, 8 sides shape is a octagon, 9 sides shape is a nonagon, 10 sides shape is a decagon. These are leading shapes of polygons.
Now Kemakya will lead us in explaining the types of polygons used in their mansion.
I'm going to explain the key shapes used in a math mansion model. This model shows how mathematics is used in real life buildings. First, the main house structure is made using cuboids. The rooms, walls and the base of the house are all cuboids in shape. Cuboids provide more space and make the building strong. Next, the roof of the house is made using a triangular prism. This shape helps rainwater flow down easily and protects the house. On your right side, you can see a tower made using a cylinder. Cylindrical shape are strong and are often used in pillars and tower. On the top of the tower is made using a cone. Cone shape give a beautiful look and is also useful for ventilation. The windows and doors are all made using rectangles and square. Shows that everything are used in these also. In front of the house, the swimming pool is designed using a cupboard. Cupboard give the holes to help hold the water evenly. Even the trees around the house are all made using cones and cylinder. Shows that 3D shapes are used in nature too. To conclude, this mathematics shows that 3D shapes are not just a part of mathematics. It is an important part of real life. Thank you.
Do you know how to add an interior angles in a polygon? Now Kavistri will teach us to add the interior angles in a polygon through her model.
This is a model to find out the sum of interior angles in a polygon. We can find the angle of any polygon with any number of sides by using this model. We should use this thread from the center and make any shape by enclosing it in these screws. Then turn the protector at each point such that one point is coincide with the zero of the protector. Similarly, for each point, note down the angle and add them all to know the angle formed by the shape. We can also check them by using formulas. N minus 2 into 180 degree, where n is the number of sides. I will do one for you. Now I am forming a square. The first angle is 90 degree, second 90 degree, third 90 degree, and the last one also 90 degree. Thus 90 plus 90 plus 90 plus 90 is equal to 360 degree, which is angle enclosed by a square. By using formulas, n minus 2 into 180 degree, where n is equal to number of sides. 4 minus 2 into 180 degree, 2 into 180 degree is equal to 360 degree.
Now Subarna will tell you about the parts of circles.
I am going to explain about the circle and its part. Circle. A circle is a path traced by a moving point so that its distance from a fixed point is always constant. Center. The fixed point of a circle is called its center. Radius. Radius is the constant distance from center to any point on a circumference is its radius. Chord. The line segment joining any two points on a circumference is called a chord. Diameter. Chord which pass through the center is called as the diameter. Arc. A part of the circumference of a circle is called as a circular arc. Secant. A secant of the circle, the straight line that intersects the circle at two distinct points known as passing through its tangent. A straight line that intersects the circle at exactly one point known as the point of tangency or constant.
We all have seen bicycles and we have also used it. Have you ever seen bicycle? Pi is a value that we use in doing calculations involving circles. Its value has no ends.
Types of triangle. On the basis of sides, triangles are of three types. They are equilateral triangle. All sides are equal. They are called equilateral triangle. Isosceles triangle. The two sides of the triangles are equal. They are called isosceles triangle. Scaling triangle. When none of the sides of the triangles are equal, they are called scaling triangle. On the basis of angles, triangles can be classified into three types. They are right angle triangle. When one angle of the triangle is 90 degrees. Acute angle triangle. When all the angles of the triangle is less than 90 degrees. Obtuse angle triangle. When one angle of the triangle is greater than 90 degrees. Uses of triangles in real life. In real life, triangles are mostly used in architecture. Thank you.
Right-angled triangles are used to find the unknown value using Pythagoras theorem. Now Sudhir Sai will tell you about the Pythagoras theorem.
I am going to explain about Pythagoras theorem. In a right-angle triangle, the square and the hypotenuse is equal to the sum of the square on the two sides. This is a working model of Pythagoras theorem. It has three squares built on the side of the right-angle triangle. If you fill the square and the hypotenuse and rotate, will be transferred to the other two squares and fill them. This proves that area occupied by the break square is equal to the area occupied by the other two squares. In the case of rising secants in garden, without damaging the garden, we can make this sentence answer as. Thank you.
Now Kamlesh will tell us the use of triangles in today's architecture.
Mathematics in architecture. Mathematics plays a vital role in architecture, especially designing a strong and safe structure. One of the most important mathematics shape used in architecture is a triangle. A triangle is the strongest geometric shape because it does not easily change its form when the force is applied.
Let us take the square for example. This shape is not so steady to withstand heavy load. It is flexible, so that is a chance of destruction. But if it is converted into a triangle, by adding a piece in between the shape, it becomes so strong that we cannot alter the shape due to pressure. Hence, triangles are given more importance for its durability and strength.
Triangle helps in distributing weight evenly and provide excellent support against pressure, wind and gravity. I will give you some of example of buildings where triangles are implemented. Famous of example in triangle model in architecture is the Eiffel Tower in Paris. Entire structure using 186 triangles. These triangular frames allow this tower to stand tall bridges, strong wind and stable for many years. This tower, which is 330 meters tall, use this geometrical shape to distribute weight effectively.
Another example is a pyramid. A pyramid is a strong architectural structure based on a triangle. This is a model of world's highest ladder in Sagarmatha, Nepal, which is in shape of pyramid. This is considered as one of the world's scariest slabs in the world.
Another example is bridge, like suspension and truss bridge. Triangles or truss design are used to support the heavy loads, vehicles and people.
Next example is cell phone tower. Cell phone tower is a triangular architecture primarily for superior structure, stability, rigidity and wind resistance by using minimal materials.
In conclusion, triangle model shows how mathematics is the foundation of architecture from Eiffel Tower to modern bridge and buildings. Triangle provide a strength, stability, accuracy and beauty. Mathematics makes architecture safe, efficient, long-lasting, shaping the world we live in today. Thank you.
Time is also a measurement. This is the Big Ben clock, which is one of the famous landmarks in London. It's famous for its architecture, which involves mathematical shape, and also the massive bell weighing 13.7 tons, housed within 96 meters tall tower. Sai Prasad will now tell us the various types of clock used from ancient days to till date.
I'm going to explain different types of clock. Sand clock. This is a device used to measure the passage of time by a flow of substance from upper bed to lower bed by an arrow due to gravity. Water clock. This is a time base by which a time is measured by a flow of liquid. Candle clock. This is a candle because it is placed in all the time.
Graph is the diagrammatic representation of any data in daily basis. Gopalmadran will now explain the types of graph and its uses in daily basis.
No proportions area for displaying forms of a good. Example, this pie chart depicts the interest of students in reading various books. Line graph connects data points with lines excellent for showing high data. Changes its not prices, etc. Example, a graph drawn for the number of sides of a polygon and their section and area of polygon on the
Concept of measurement. Asif and Hamid are here to explain about the importance of measurements.
Measurement of height and weight ever limits whether or not it is appropriate for our nature. BMI is widely used as an indicator of body fat content. It is also a reliable tool for establishing this level for illness.
Many healthcare professionals use BMI to determine effective doses for medicine. People with high BMI needs higher doses. Hence, it is crucial to be aware of your BMI to ensure your overall wellness. You can check your height and weight and we will tell your BMI. Thank you.
In avoiding accidents caused by damages on bridges will now be explained by Nitish.
This model translates real-world problems into mathematical forms to analyze, predict, and solve them. The benefit of this model is that it builds essential 21st century skills, provide academic knowledge, and the ability to apply mathematical skills to practical situations. Nowadays, heavy load vehicles passes through bridges and causing damages to it and thus leading to many accidents. In order to avoid all these, we can use mathematics here in measuring the weight of the vehicle before it crosses the bridge. This consists of breaker and broken load. According to the capacity of the bridge, the load of vehicles can be maintained. In this model, breaker would allow the vehicle of weight lesser than 120 grams, but the weight is if the rate is greater than 130 km, then the needy close and launch the vehicle. In breaker 2, if the rate is lesser than 150 km, the motor is stopped and allows the vehicle to move. But at the same time, if the rate is greater than 150 gram, the motor moves and stops the vehicle from moving further. So, if this is done in a proper manner, we can safeguard bridges and avoid accidents caused by damages. Thank you.
Calculation of time is different in different countries. Here is a display of time in various countries. Speciality of these countries is that all these countries are found in between two parallel lines, and also these countries starts with the letter I. Our friends Hariharan and Nikhil are here to explain about the magic square, and they will also tell the magic using your number.
We are going to explain about the magic square. Srinivasa Ramanujan magic square is a famous 4x4 great incorporating its birth date 22/12/1887, where rows, columns, diagonals, corners and central group all sum to its magic constant 130 minutes. This 4x4 grid can also be done for any other date with another magic constant. Thank you.
Kept on various concepts that we have come across. This is a model to show the elements of math. It is a square double showing the squares of 2025. It is a factor tree which shows the factors of 2025. It is a Pythagoras theorem model which shows that the square on the hypotenuse is equal to the sum of the squares on the other two sides.
Model of a graph which contains 4 quadrants, first quadrant, second quadrant, third quadrant and fourth quadrant. This contains plus and plus, minus plus, minus minus and plus and minus. Thank you.
It is a model to show the Greek symbols with its name. Now I am going to lead you to the world of symmetry. If we get an identical image by either drawing horizontal or vertical line, then it is called as symmetrical image. You can use this symmetrical image to take your photograph. Hope you enjoyed the journey through the world of mathematics.